Okay, so today we're gonna talk about how to name the compounds from the formulas of complex compounds. Okay, so first when you're naming the compounds, you name the ligands first and then the central atom, and the ligands should be in alphabetical order. When you name any cations or neutral ligands, they stay the same. And there are some exceptions to the neutral ligand rule. For example, H2O is aqua, and H3 is amine, etc. And then anions, you need to change the ending. If it ends in I, it becomes ido or O. H becomes ato, and then I2 becomes ito. And then when you need to name how many of that ligand are there, you need to use a Greek prefix, so like bi, tri, etc. If it's a polydentate or it already has one of those Greek prefixes inside, you need to use bis, tris, and so on in front of it. So if the whole complex itself has a negative charge, then the central atom, the metal, the transition metal, needs to end in 8. And then finally, you need to make sure you find the oxidation number of that central atom, the transition metal, and then write that in Roman numerals. Now we'll do an example.
So here our ligand is cyanide, which has a charge of -1, and we know there's 6 of them, so we're going to start out with hexa, and then afterward we would add the cyano, because even though it's cyanide and cyanido, there's an old and a new way, so we can do it this way. And then we need to add our transition metal, and since this entire thing is an anion, we're going to put ferrate and have the ATE ending. And then finally, we know that this is a -4 charge, it's just 6 times -1, so it's a total of -6. So we have to add 2 to get the -4 charge, this is ferrate 2. Then for our next problem, for starters, we need to write out the ligands. So this is amine and this is aqua. So this is going to go first alphabetically. There's 6 of them. So it's going to be hexaamine. And there's 1 aqua. So that's going to be aqua. And then we need to have the charge of our transition metal. So we know that bromine is -1. There's 3 of them, so it's -3. These are both neutral ligands. So that means that this entire complex needs to be +3, and thus the cobalt will be +3. And so we have cobalt 3, and then we add the bromide at the end.
Okay, so now we're going to go through the steps of going from the name to the actual formula. So the first step is to make sure you have your transition metal first, followed by the ligands in alphabetical order. After that, you have to identify the number of ligands by using 2, 3, or 4 based on what the Greek prefix is. So if there's di, it would be 2, tri would be 3, tetra 4, etc. And then if there are anions outside of the complex, you have to make sure the cation is before the anion. If there's neither, then there's a chance that that complex ion may have a charge, and you need to calculate that charge and put it at the top right corner of the bracket.
Okay, so I'm going to take these names and then change it into the formula. First, I'm going to start out with the ligand. Amine is NH3. Okay, and then it says penta in the front, so that means there's 5 of them. Okay, and then there's the sulfato, and then that's going to be SO4. Okay, and then the cobalt goes in the front, and then I'm going to bracket that. And then put the chloride at the end. And then now I'm going to do the charges. Chloride has a -1 charge. SO4 has a 2- charge, and there's only 1 of them. This is a 0 charge, and then the cobalt is going to have 2, 1, so that's going to be a +3 charge, and that's fine. And that's supposed to be right because the cobalt has a Roman numeral 3. Okay? So for the next one, I'm going to do the ligand first again. So I'm going to put En. It says bis because it's a polydentate, so then I'm going to put a 2 right here. And then you have hexanitro. So then I'm going to put NO2, and then hexa means that there's going to be 6. And then ferrate is iron, so then that's going to go right here. And then I'm going to bracket it. And then this has a -6 charge, and then this has a neutral charge, and then the Roman numeral indicates that the ferrate has a 3 charge, a +3. So then the overall compound has a 3- charge.